Hey, Radhe Radhe, everyone. All right, so it's the third live session that I'm organizing. In this particular live, I'll try to cover. Oh wait, what happened? All right, all right. So now we'll try to cover some of the domains as well as some of the topics that have been mentioned in some exams, some the CNCF certificates as well as courses that are available. The main topic for today is the platform engineering. We'll try to cover some of the domains as well as some topics that are being involved as a kind of a syllabus or some things or some topics that you should be knowing as a platform engineer or as a platform engineering associate. So we'll try to cover them all, and I have a whole document. Maybe I can share it as well to you guys. Maybe in the description, let me find how can I put it over there in the description. All right. So for this summary, for the live three, I have provided it. Other than that, for the whole syllabus or the topics or domains for the CNPE and CNPA. Let me put a link to there as well. Let me see if I'm visible. Yeah, I am. Let me switch off my Docker that's been running at the moment. It might be engaging a lot of the CPU and memory. We'll try to cover most of the topics that are present right now through while with the help of some of the. Let me first share the link. It won't look good while I'm busy in something else and. All right. So I have entered the link as well. Let me share my screen. CNPS syllabus. Let me first try to show some of the, or either, yeah, right. So here's the whole syllabus. I might say the domains. Yeah, the core, the domains as well as some of the topics that we should know about. CNPA stands for the Cloud Native Platform Associate, Platform Engineering Associate. That's why it's been termed as CNPA. Other than that, it's more kind of an intermediate topic, it is not as much advanced as compared to CNPE. CNPE is the Cloud Native Platform Engineer. So these are different topics. Oh, why can someone? Right, so here we have some of the topics that have been mentioned. One of them is the declarative resource. We does know about some of the topics as I'm pretty engaged in the whole cloud and the cloud native world at the moment, or either the DevOps world as well. So I just have some of the knowledge about these particular topics. So we'll try to cover them all, and we'll try to get the whole knowledge as if I'm a beginner, as if I'm a newbie, because I'm live at the moment. So we'll try to cover them all through the basic definition. We'll try to know about them all through the docs as well. You might be knowing about the declarative approach for the resource management, for the DevOps practices. These all are kind of the introductory topics. For the observability stack, if it is traces, metrics, and logs, one of the project that is well known in the whole ecosystem of the landscape is the OpenTelemetry. So we'll try to get over or go through the whole entire docs that are present at the OpenTelemetry project. Other than that, if we want some more knowledge about these whole particular, any particular topic, then we can also move ahead on the YouTube and just enjoy some of the videos that has been uploaded by some, some engineer, some platform engineer itself. So we'll try to cover them all. Continuous delivery and platform engineering. Continuous delivery is mainly for the, the Argo rollouts and Argo CD. And some other projects as well. It can include the Flux as well, or Argo, or some other things as well. Jenkins is majorly dependent upon the CI/CD. That's for the deployment part. But for the delivery part, we might go along with the, the Cargo or Argo CD, and some other topics as well that are present at the moment. I might also share my screen, share the whole landscape as well, so that we can get to know about some of the topics that are well known in the whole industry for these whole basic functionalities. Let me know if I'm audible at the moment. How many people have joined? All right, if you're present in the moment, yeah, I would love to hear your thoughts, or I would love to get some of the live chat as well. Uh, yeah, my internet is all right. All right, so let's start with the most basic kind of thing. Any particular engineer or any a student might do. They might search it on Google. They might Google it, or either they can just search it on the Gemini. At the moment, nobody's been using Google as much. We can even ask Gemini to find some of the nice docs for us. All right, so let's ask about these topics. Declarative resource management, DevOps practices in platform engineering. All right, so let's ask it. All right, so let's see. What do they say? Mission goal. Hey, thanks for listening. All right. Am I visible? If this, yeah, this whole tab is visible. All right. If the introduction documents are not directly returned for research, the topics under the platform engineering seems the landscape is wide. Yeah, I know. Right, the approach. Yeah, it's just giving the basic whole introduction about these particular topics that won't help, I guess. It, all right. Declarative approach, if you already knows about that. Declarative resource management. So there are two ways. One of them is the imperative approach, another one is the declarative approach. In the imperative approach, you write down about each and every particular step that has to be performed in order to reach to a final state of your architecture or your workloads. Let's say if you want to build an architecture, yeah, an infrastructure for your application, or let's say you want to manage the S3 buckets and you want to decrease the latencies, then you might say write down some of the steps that you knows about or your system engineer might be knowing about, and those particular steps would be performed either by you or either by your engineer or either by the particular application either that you are using at the moment. But that will include a lot more knowledge that has to be present along with the system engineer or some other engineers as well. I'm not saying that the declarative approach won't require you to be having a lot of information, but still, declarative approach is just like you'll just mention the final stage, or the the kind of the status or the stage that you want your application to be in, as a, what should I say? like the current status of your application and the what can I say? How can we define it? All right. So one of them could be the current state of your application and the required state of your application that you want at the end of the whole process. That all particular steps that has to be mentioned or will be managed, and that all will be done or will get performed by the application itself. So that will be a declarative approach in which you will just declare the final the status of your application, and the rest of the actions or the steps would be taken care by the application itself. A lot of most of the applications that are involved or being present at the moment in the whole CNCF landscape, all of those are follows the declarative approach. Whether it is the Argo CD or Open Telemetry. The Open Telemetry is not about taking or performing in particular kind of an action. It's about standardizing the whole observability stack. Uh, all right. That's the whole declarative approach. That's what it's saying. Yeah, orchestration and management. Understanding the Kubernetes declarative model is central. Projects like the Flux, Argo CD, that's what I said. GitOps as well. Yeah, the major the model that's been considered for this particular approach is the declarative GitOps approach. The Git and operations. So that's why. The DevOps practices in platform engineering, cross-cutting discipline, ties into almost category. And these all kind of, these all are the topics that you might find them on the YouTube. You might find a lot of people giving, talks in KubeCon or CloudCon or a lot of, the cloud conferences as well, or the platform engineering conferences. They are not, separate topic. Obviously, they are considered inside the core functionalities, so that's why you can't consider them as a separate topic. You might consider security and conformance, observability fundamentals, and traces, matrix, logs, and events. If someone doesn't know as much about these particular topics, then they can be considered as a separate topic. Other than that, if you're a DevOps engineer or either a software engineer who does hold some of the knowledge about the whole development process, then it won't be a huge problem for you. Let's see. So, all right. So sources, applications, environments, and infrastructure concepts, containerization and orchestration and management, right? Platform architecture and capabilities, platform engineering goals, objectives, and approaches. That is an important topic. If someone doesn't know as much about this whole platform engineering thing, then it could be a really amazing topic to study about. Right. Um, and the one would be the continuous integration fundamentals, CI/CD pipeline. CIC, all right. Continuous integration and delivery. All right. I know where to find this particular topic, which docs would help. Continuous delivery and DevOps and GitOps. Both of these are kind of same projects like Flux CD, Argo CD. So it's all about the declarative approach of the platform engineering. Your platform, the core functionality of platform engineering is that, yeah, your platform, which will be running a lot more, which will be integrating with a lot of different tools, whether it is for the the chaos engineering or whether it is about the gateway APIs, following gateway APIs or the Kubernetes or handling the AI workloads or a lot more things, either the core cost operations or either for the FinOps engineering. All of those things have to be integrated in a way that it will reduce the over computation part of your platform. It should lead to a better platform success. It should bleed less amount of money from the pockets of the project owners or the admins who are at the moment administrating the whole platform or who are responsible for um, spending of the whole expenditure part of your application or your project. So it should be mannered in a way, it should be designed in a way, your platform should be designed in a particular way, in a standard way. Like they use, all right, so let me start the whole introduction from my own the understanding. Uh, Let's start from the beginning. When the whole software engineering part was developed, they had separate teams. One was the one who used to develop the whole application or your network pipelines and all of those things. Not the network pipelines; they were the operations and the networking team. All right, so let's only consider about the software developer team, right? Which you consider as the SD at the moment. So the software developer team, they used to just engage themselves in designing or the development of the whole application. Another team used to be the security team as well, or the networking team who used to lay out the whole network for your application. It should work in a way so that the servers would be up and running at all the moment, and it won't cause as much problem for the users or either for the developers as well. And the other one was the operations team who used to deploy your applications into the cloud or either on the servers and used to just monitor if your servers are running at the moment. And all of these particular teams didn't used to know the task that was actually going on at the other side of the other side of the bridge or the country. Yeah, whatever you say. All right, so like the developer teams only used to maintain or develop their application, that didn't know anything about the operations team. Or and same in the similar way, operation teams didn't used to know anything about the developers team. So there used to exist a lot of gap in all of these particular teams. If there used to be any particular kind of a bug that was being found at the ops side, then the developers just used to raise a ticket, like a Jira ticket or anything else, from the ops side, and they used to ask it that this particular problem has been found at the moment, and the operation team used to work on that. But if there would have been any particular kind of an error from the developers side, they didn't know about it either. So that's why it used to be a huge problem or a huge difference between the particular knowledge that was being present at the moment between the ops team and for the developers team. That's why later at that stage, DevOps whole field, DevOps was introduced. DevOps stand for the developers side as well as for the ops side. The ops used to be ops, stands for the operations team, which used to take care of the whole deployments and all of those particular things, even handling your servers as well. So DevOps used to be a particular team that used to play as a kind of, I would say, the middleman or the gateway between both of these particular teams. They used to have some of the knowledge about the developer side as well as about the operation side as well. So they used to handle both of these particular teams. They used to communicate or cooperate along with their teams in a way such that this whole gap between the developers as well as the operation teams could be reduced, or can it won't get, yeah, it might get disappear as well as it is getting at the moment right now these days. But the problem was that DevOps team slowly became kind of an ops team at many sites. They didn't know as much about the developers side either. They kind of become the same as the ops team. They started integrating a lot of useless kind of the tools that was not being as much required, that wasn't required as much for the applications at that moment. But that kind of brought a change in the whole life cycle of the development, which was that the developer side started knowing something about the operation side as well, and the ops side started learning something about the developer side as well. In that way, both of these anyways, this particular kind of the difference reduced a lot. But like in the long run, at the moment, let's say, like I'm at Facebook. I'm having a lot, I've been working at a lot of different features. Like at the Meta, you might be working for the Facebook, and the another team would be working on the Instagram. There could be within Instagram as well, there could be some team which will be working on the the collaboration part or either about the reels part. Some of them could be working on the stories and many other things as well. So all those particular teams will be having their own DevOps team as well, or the engineering teams as well, and those teams might integrate some tools or some frameworks that they some kind of internal tools either that their team might have built for them, so that those tools started varying at every particular level in the whole organization. Let's say the Instagram have been using Terraform for the IAC as an IAC tool, but the the Facebook have been using Pulumai or the OpenTofu for their IAC part. So that added up a lot of complexity for their infrastructure as well. In that case, it would have been a lot better if they could have settled for a single standard tool that will be applied or that would be used for the whole organization. And that's where the platform engineering came for the whole moment. uh, Facebook can be considered as a kind of a platform for the whether it is for the developers or either for the the users or the clients as well. So for the whole platform, they might be having a lot of standard tools that has to be used in that certain way only. Like you'll have to use only Pulumai or either the. So my network is kind of unstable. It's going on. It's all right. All right. No problem. Let me complete it. All right. So that's what happened in the whole sequence. The platform team started standardizing a lot of some tools or either some of the the frameworks or internal tools that were being built at that moment. Some of the practices as well for the platform success. Other than that, as well, they started building some of the platforms in a way such that the learning curve of this whole ops or either about the developer side could be made lesser steeper. Learning could be made a lot easier as compared to the earlier part. So like if any particular developer is engaged at the moment in building up something and he want to include that particular feature, or he just wants a testing environment at the moment, and for that testing environment he might need a testing pod or the cluster that has to be open for him or either for his team either. It can be considered as a kind of deployment or either about the the testing purposes first of all. So for the testing purposes, he might open a separate cluster or either a pod for each and every particular feature that would be added. And for that, instead of just opening up the whole Jira ticket or either asking from the DevOps team, they might just ask for a cluster or either a pod to be made from the platform itself, and platform would be provided with some kind of the scripts or the basic or default features or the capabilities by which if a developer would ask for certain things in a certain way, then they can get it instantly without taking as much time, so that the efficiency could be increased, time could be wasted lesser compared to the earlier time. So yeah, it will be an amazing change in the whole development cycle. The platform engineering or the platform engineers could work really in a better way. Their main motive is to take care of the platform success, and there are a lot of platform evangelists as well that you might find in your organization where you are working at the moment. They will be taking care of all of these particular things. Other than that, the platform engineers will be taking care of the separate, the branches within your organization. Evangelists will be like kind of the advocates will be taking care of your platform teams or your branches either within your organization or outside the organization as well for in various conferences. So yeah, let's try to uh, know a bit more about these particular topics. Let's start with platform architecture and capabilities. Conflicts of IAC. All right. Let's try to understand about the platform engineering goals first of all. IAC is a different topic. You might consider it kind of an important one at some other day, uh, either at some other time. What's happening? Right. Let's try to watch this on others. Yeah, let's try. And right, yeah, let's try to minimize this particular kind of a confusion that you might be having at the moment. If it is all about the boss, then why have you, why engineers have created a separate kind of a term for the whole DevOps team? If the DevOps team isn't able to work efficiently as much they were expected earlier, then why the platform engineering term was actually being coined. So let's try to understand what's the difference between both of these particular terms, and then later we'll try to cover what is platform engineering, what are its, some of the goals, and what does it take. Yeah, sure. We might consider watching some of the talks as well. It will be an awesome topic. Am I audible? Is this particular video is all audible on the screen? Right. No, it isn't being shared. Oh, no, it's being shown. Not. Is it visible? Can anyone maybe help me out? On my screen it is, but from a separate account that I'm seeing at the moment, the whole video section isn't visible, I guess.
Hype is all about? Or are you just tired of these blurred lines between platform engineering, DevOps? Have you been hearing about this hot new trend of platform engineering, but you're not really sure what the hype is all about? Or are you just tired of these blurred lines between platform engineering, DevOps, SRE, and all the rest? Well, in this video, we'll dive into the difference specifically between DevOps and platform engineering and explore why platform engineering may be the solution to your problems. Hi, I'm Luca from the platform engineering community. In this video, we're going to discuss the differences between DevOps and platform engineering and why platform engineering may be the solution to your cloud native setup. So first of all, we need to start with a quick walk down the software engineering memory lane and look at how it all got started. When DAOs came up more than 10 years ago, the world was a very different place. We mainly developed monoliths, often running on bare metal. Our infrastructure was way less complex. There was no Kubernetes, no Terraform, no infinite CNCF landscape of tooling. And the initial idea behind DevOps was great. It was simply to remove the barriers between developers and operation teams and facilitate collaboration. The reality of DevOps today, however, morphed into something a lot less ideal. With the convergence of cloud-native technologies and trends like Kubernetes, infrastructure as code or IAC, GitOps, and pick your buzzwords du jour, the day-to-day of most developers has become incredibly complex. So let's say as an example that you want to deploy a simple change to your application and test it in a preview environment. Well, 10, 15 years ago, that would have probably meant touching a script and one or two tools. Today, that has exploded to multiple scripts, Helm charts, YAML files, Terraform modules, and a bunch of other cloud-native tooling you're just afraid of touching for fear of screwing things up. So this idea of you build it, you run it, in practice really just translates to developers being blocked and having to wait on operations teams to come to the rescue. And these ops teams are under increasing pressure and become a huge bottleneck to the org velocity. The situation often leads to ticket ops and DevOps burnout, undefined responsibilities, and in general, just a toxic relationship between developers and operations. And that is why platform engineering emerged, especially among leading tech companies and top performing organizations. They realized that they needed to build some sort of platform layer between developers and operations to enable developer self-service and ensure their setup could scale while also maintaining their governance and security standards. So platform engineering is the discipline of designing and building toolchains and workflows that enable self-service capabilities for engineering organizations operating in the cloud-native world. Platform teams build an internal developer platform, or IDP, which is a layer on top of the tech and tooling your team has in place already and binds them into golden paths that developers can follow to interact independently with the underlying infrastructure. They can self-serve environments, databases, and whatever they need to run their apps and services without having to wait on ops. Platform engineering therefore aims to fix broken and toxic relationships between developers and operations by enabling self-service for developers and allowing operations to focus on infrastructure challenges and not spinning up yet another environment. Several studies at this point have shown that internal developer platform usage highly correlates with higher DevOps evolution and performance. Gartner has recently named platform engineering as one of the top 10 strategic technology trends of 2023, predicting that by 2026, actually 80% of software engineering organizations will establish platform teams as internal providers of reusable services, components, and tools for application delivery. Thanks for watching this video on the differences between DevOps and platform engineering. If you found this content valuable, don't forget to hit the subscribe button to stay updated on our latest insights and trends in platform engineering. Have you been hearing about this hot new trend of platform engineering? This video will platform community. In this video, we're going to So, have you been hearing and read about platform engineering all over DAO's Twitter, but you can't really get what the buzz is all about? Everyone seems to be so excited about it, yet you can't see how it's different from DevOps. You came to the right place to figure it all out. Hi, I'm Luca from the platform engineering community. In this video, we're going to be setting the record straight on the emerging discipline of platform engineering. We'll give you a precise definition, explain how it fits into the larger cloud native and development ecosystem, and what its main differences from DevOps are. We'll also discuss the value of platform engineering for both ops and developers, and how it connects to an internal developer platform. Finally, we'll talk about the main challenges platform engineers face and offer some advice and best practices. So if you're ready to learn more about this new frontier of cloud ops, let's get started. So what is platform engineering? It is the art of binding all of the different tech and tools floating around in your delivery setup into clear golden paths that enable developer self-service and reduce cognitive load on individual contributors. some best practices. So if you're ready to learn more about this new frontier of cloud ops, let's get started. So what is platform engineering? It is the art of binding all of the different tech and tools floating around in your delivery setup into clear golden paths that enable developer self-service and reduce cognitive load on individual contributors. The sum of these golden paths is most often referred to as an internal developer platform, or IDP for short. The IDP is built by a platform engineering team following a platform as a product approach, which means the platform team needs to treat developers as their own internal customers. But why all the buzz? Well, it's actually quite simple. Platform engineering is the answer of top performing engineering organizations to avoid the pitfalls of today's DevOps reality. While you build it, you run it is a great concept in theory, the day to day practice of DevOps is broken. Developers are overwhelmed by increasingly complex cloud native technologies and need to wait on operations to do anything that goes beyond the simple update of an image, really. So the Airbnbs and Spotifys of this world who had to add hundreds of developers every month quickly figured out that the only way to actually enable developer self-service and ensure you build it, you run it, was simply by building a platform layer in between developers and operations. That layer is what we call an internal developer platform, or IDP for short, and it's the end product of platform engineering. All right, so what's in it for operations team? Well, they are no longer drowning in ticket ops, and they finally have more free time to work on strategic initiatives rather than reacting to issues and requests from developers all the time. Also, their delivery setup is compliant, secure, with highly standardized services and infrastructure that are easy to maintain. Change failure rate drops, and all your DARA metrics improve across the board. For developers, on the other hand, they can now ship faster by self-serving their workload dependencies without talking to ops. They can easily spin up PR environments, new services, and resources without having to understand Terraform or Helm. They no longer need to write and maintain app and infrastructure configurations on their own, which also keeps senior developers away from doing what we call shadow operations. Sounds great, right? And it is, but platform engineering is still very much in its infancy, and with the young age also come challenges that still need to be addressed. The main one we see is about communication. Many platform teams fail because they either don't build the right feedback loop with developers to allow them to quickly iterate on the features of the internal developer platform, or they fail in communicating clearly the ROI of the platform initiative to executives. And that is where meeting other platform engineers and sharing best practices can really make or break your platform initiative. This is why our platform engineering Slack recently crossed 10,000 members, and the community keeps growing and hitting a nerve in the broader DevOps industry. So come join us. We'll drop the link below. If you found this video on platform engineering helpful, be sure to subscribe to our channel to join